This video is about how to multiply and divide real numbers. It's a bit of a review on this topic, and we are in the context of beginning or elementary algebra class. And we'll start with some examples where we want to evaluate. In the first, we'll say -5/7 times -3/8. Well, as we've already seen at this point, when you multiply a negative times a negative, you end up with a positive value, and then when you're multiplying a fraction with a fraction, we simply multiply straight across the top and straight across the bottom. So we'll end up with a positive answer, and then across the top, 5 times 3 would be 15. That's just multiplying those numerators together. And then across the denominators, 7 times 8 would be 56. Of course, we always check to see if we can reduce our answer by dividing the numerator and denominator by, the same number, some kind of common factor. But it turns out in this case that there is not one, so we can stop right there as our reduced answer, 15/56. Moving on to a second example, we'll multiply -6 times -3 times +10. Well, with a string of 3 numbers being multiplied together, you could pair them up really in a couple different ways, but it probably makes simplest sense to go just left to right, which is what we're used to for addition and subtraction. So if I take the left pair first, the -6 times the -3, of course a negative times a negative is positive, and 6 times 3 is 18. So that pair would result in 18, but I must bring down the 10 at the end here that I haven't even touched yet. And then we kind of start over and do the same thing, but we only have 2 numbers now, so 18 times 10 would be 180, and we can stop right there. Moving on to a third example, this one just strings more numbers together. This is the product of 5 numbers. I'll read them across. We have -9 times -12 times -18 times 0 times -3. Now, in this case, you could pair them up like we just did in the previous example, where you do the first 2 and then kind of recopy everything and do the next 2 and so on. But if you just take a quick glance down this string of numbers, you'll notice one key player here, which is this 0 tucked in as the second to last number. Anytime you're multiplying by 0, the product ends up as 0. So all the work we could do to pair up 2 at a time and work our way down left to right would end up being useless because of this 0. In other words, if you're multiplying a string of numbers times 0 anywhere in it, then the result is going to be 0. Now let's add a definition here that kind of relates multiplication to division, and that is this. A multiplicative inverse is also called a reciprocal. So reciprocal is kind of a vocabulary word that you're going to use really going on in any algebra course. And so examples of reciprocals would be like 2 and 1/2, or -1/6 and -6. Let's observe these examples and see if we can understand this idea or definition better. So reciprocal, in some sense, means you flip the number upside down. If you look at the example of 2 and 1/2, 2 could be written as 2/1. Any integer or real number could be written over 1. It doesn't change the number. That's just a way to understand a number as a fraction. And if you understand or see it that way, then, of course, 2/1 and 1/2 would be like flipping the number upside down. You're just changing what's the numerator and denominator. Similarly, with the second example of -1/6 and -6, again, if you see -6 as a fraction over 1, then this works the same way. You simply flip the number upside down. And so that's one way to understand a reciprocal. Now let's work on some other examples where we want to evaluate. For the first, we want to use 40 over -5. In other words, 40 divided by -5. Well, this is a fraction which communicates division. And so as we've already been seeing, you can utilize a lot of the reducing and sign rules for fractions to do this. In this one, we have a positive number 40 over a negative -5. So when you see a positive over negative, 2 different signs, the result is going to be negative. And then we simply reduce this as we can. Now 40 over 5 would be like 40 divided by 5, which happens to be 8. And so we could say negative 8 is our result. For our second example here, we have 0 over negative 6. Well, anytime you're dividing the 0 by a number that's not 0, so 0 over anything else besides 0, the result is going to be 0. In contrast to that, the third example has negative 6 over 0. So notice the difference between these two examples, numbers 2 and 3 here. In the first case, number 2, we just did, the 0 is on top. In number 3, the 0 is on the bottom. You could say that those are reciprocals if you use that definition above. They're just flipped upside down. And furthermore, when you have 0 in the denominator, it's like trying to divide by 0, which actually doesn't make any mathematical sense. So we just say that this is undefined. We cannot divide by 0, and so we'll say undefined for the result of that one. And then for our fourth example, we have 1/5 divided by negative 1/5. Here, we'll understand division of fractions like we have already, which is the keep, change, flip little segment there. So we could say keep the first fraction, 1/5. We're going to change from division to multiplication, and then we're going to flip the second fraction upside down. So instead of negative 1/5, we're going to flip it to be negative 5 over 1. Okay, that's just the keep, change, flip idea to handle division of fractions. And then, of course, to do that division, which is now just multiplication, we just multiply straight across. Of course, a positive times a negative will end up negative. And then across the top, we have 1 times negative 5, or just 1 times 5, because we've already put the negative sign in front here. And then down below, 5 times 1, which is 5. So we have negative 5 over 5, which is really just negative 1. And so that's our result of doing the division of those two fractions.